Hallo und herzlich willkommen zu Data Science mit Milch und Zucker. Mein Name ist René und ich freue mich, dich in die faszinierende Welt rund um Data Science, Datenanalyse und künstliche Intelligenz zu entführen. In jeder Episode werde ich mit renommierten Experten sprechen und dir praktische Anwendungsfälle sowie die neuesten Entwicklungen aus der Welt der Daten näher bringen. Und das alles in Bezug auf den deutschsprachigen Raum. Also schnapp dir deine Tasse Kaffee, Tee oder was immer du auch bevorzugst und lass uns gemeinsam in die Welt der Daten eintauchen. Mit einer Prise Milch und Zucker. Hi and welcome to our next episode of the podcast Data Science with Milk and Sugar. Today we have as guest Mirza Klimenta. He will talk about Recommender-Systems, Falcony AI and also other interesting data science projects. I'm happy that you're here today.
Thanks, René. Thanks for having me.
Maybe you can make a short introduction about yourself, maybe also in relation to Falcony AI, what you do over there.
Sure. So my name is Mirza. Originally, I come from Bosnia. I studied computer science at the University Sarajevo School of Science and Technology in Sarajevo, which was the first English-speaking university of that kind in the territory of the former Yugoslavia. After my bachelor, I started my PhD here in Germany at the University of Constance, and it was in the Algorithmus group because I was very interested in anything that has to do with algorithms. I remember that during my studies, I was obsessed of how to make algorithms faster, so the sorting algorithms and also the data structure, so how to extract the minimum, maximum values and so on. And I got a very nice project back then. It was in the field of graph drawing, which today it will be like graph embedding, obviously in machine learning. But back then it was in 2D and 3D, so it was visualizing in two-dimensional space, and I was using some dimension reduction techniques to achieve this goal. And so my dissertation has a couple of contributions, very interesting, and part of it is was what my passion is, which is improving the speed of the algorithm. So we managed to, for instance, one algorithm, we managed to improve the speed. It was an iterative approach, and the time complexity was quadratic per iteration. And we did an approximation, reducing it to a linear. And we won actually the best paper award back then in the graph drawing conference. And so after obtaining my PhD, I worked in Karlsruhe in automotive industry. But then I said, okay, it was not really, an algorithmic challenges rich environment. So I moved to Italy, to University Roma Tre in Rome, where I did my postdoc. But this was purely theoretical contribution. So I was working on the morphing of graph drawings, which is why I decided, okay, let me go back to industry, collect data science experience. So I moved back to Sarajevo. I started working for a company where we did stock market prediction via graph series analysis. And after that, I came back to Germany, so here in Munich, where I worked for Bayerischer Rundfunk. So I designed and worked on design and development of the recommender system powering ARD audio tech. And so you mentioned already. So right now I'm a founder and CEO of Falcony AI, which is a consulting company. We provide AI solutions, so machine learning data science solutions for other businesses. And we actually intend to, it's pretty broad, right? It's pretty general. So we intend to specialize a bit. And the specialty would be definitely in the field of recommender systems. But what is particularly interesting to me in the past days is the causality. So inferring causality. So we as a data scientist, we know what correlation is, but correlation does not necessarily imply causality. And I think this is a good market opportunity, like for us to start also exploring that area. Exactly. So maybe a little more elaborate than you imagined introduction, but
Yes, very nice introduction. I don't have to do many things, so
exactly.
Very nice for me.
Perfect. Yeah, so I can continue it.
You don't have to talk too much. Very nice. Also about the topics, graph series analysis with in the finance market. I also have a master student who's doing graph neural networks, predicting stocks. But this is a different topic. But maybe it's interesting for another podcast one day. Just want to mention it. Today we will focus on recommender systems and also the causality, which you mentioned. It sounds really interesting because normally people talk about correlation often, and there are these famous spurious correlations where you can Google in the internet and you see the number of drowns in swimming pool correspond to the number of movies Nicolas Cage was in a year. So you have these spurious correlations. And as you mentioned, it's very important to focus also on the causality that you say, okay, this is caused by the other aspects. I would really also dive a little bit in this one. Do you have any examples or how to get the causality? I think there are a lot of challenges to achieve this.
No, as for the causality, actually, what we did, we actually started a course there on the causality. So there is a good course by the how they call it, Up Limit. Up Limit previously it was Core Rise, and they provide a pretty good course on the causality. So it was like an introductory course, but from there one can start and learning about the models and so on. What we basically, it was just a pulse sensing for us, so we didn't deep dive into it yet, but we saw that it would be like a extreme added value for businesses, which is why we said, okay, let's dive deeper here. And there are, at least to my knowledge, I mean, comparing the number of companies that provide AI services or recommender services relative to the number of companies that provide causality service, then it's a huge opportunity for us. So I hope that someone listening to the podcast will also be my competitor tomorrow.
And how can you do then the causality? Do you apply it in the recommender systems that you really say, okay, users, they bought, like, let's say, online shop or some Netflix movie, or let's say if somebody bought this product, you recommend also the other product, and then you put there the causality.
Exactly. So this is the original idea of how we would try to rationale to basically justify certain moves that we do with the recommender systems, but not only recommender systems, right? So it can be let's say that we had a project, initial project with Caterpillar, which is this big company building big transportation vehicles, and then they are interested in the how we can predict which parts are going to be replaced at what point in time and so on. So for them, basically, the causality can also play a role. So I'm just giving some examples. So it's I mean, on top of any other predictive models, if we can infer some causalities, that will be like extremely new added value.
All right. And one challenge, as we mentioned, is the causality. And do you have other challenges in recommender systems once you apply them? If it's some library, Mediatek, online shops, I think there's various use cases in this.
Exactly. So I can tell actually this very interesting story, because we had a client where we do recommendations for an online sport betting shop. So you can imagine that now the requirements are quite different. Let's compare the ARD Audiothek. So there, ARD Audiothek is a non-for-profit organization, so an app where users can log in, then they can listen to the content, and the objective is to provide recommendations such that they continue listening to the audiothek content, right? So this is the objective of the recommender system. And let's say that the collaborative filtering paradigm is particularly suitable here, right? So the users that tend to consume similar content will also tend to consume similar content in the future. However, now the story changes a bit when you consider the online betting shop, right? On sports betting shop. Now what is the objective? So the objective is to make the user continue betting. So make him like the bets that you are recommending, but also the interest of the owner of the sports betting shop is to earn money. So this translates in make the user actually like the recommendation and make him lose, which is kind of a shady deal on the side of morale. But this is then the challenge, how to satisfy both sides. So there is then what we did is the analysis on the number of users who are described as heavy users, and then the occasional players, occasional people that place bets. And then we have to kind of calculate and then fine-tune the recommender system algorithm such that both parties are satisfied. Both parties in a sense that the majority of the people actually continue to visit the online bet, but still that there is some money generated on the side of the owner of the online betting shops. There that we had a challenge was actually using the models that we thought might serve well, but in this case for the online betting shop collaborative filtering paradigm, so the users that tend to place bets on the similar bets tend to place similar bets in the future does not hold. So the paradigm does not hold, which is, so the users are practically more interested in, there is not like, okay, if there is like a user A place bets in a Champions League, 2 bets, and then the other in just one, then it makes sense to recommend the other one. Users are interested. There are some passionate users, obviously, but most of them are interested only in the amount they could win. So it's the actual teams that play. So if we apply any additional item features on the sports team, it doesn't actually make any difference. So, which is why why we had to perform quite a extensive data analysis in order to understand the user's behavior and then to proceed with fine tuning of some of the models. Obviously, there are models that we tried are the factorization machines, Light FM, and also what we actually had a very good experience because we did everything through AWS. There is a recipe in AWS. I think it's based on the hierarchical recurrent neural networks, and this was actually a model hard to beat. It was pretty good, right? So the precision that we measured, it was very high, and we struggled actually to come close to it exactly. Although we did not. It is served as a black box, right? So we still don't know about the actual parameters and so on, but it served quite well. Yeah. So this was obviously one of the challenges. And there are also the challenges about the model training. So how often the model will be trained, or whether it will be like session based in real time, providing recommendations and so on. I think this was something very, very interesting. And there is quite little research in recommender systems for online betting shops, but the field is very interesting. I think most people actually don't want to do this because, I mean, once you tell them what the requirement is, okay, so make the users like the bets that you're recommending, but also make them lose. It's it's something that you say, well, I'm not going to do this, but it's very interesting. So how to keep both parties satisfied?
Yeah, but it's also similar probably to an online shop. Of course, it's different maybe from ethical perspective, but also online shops, I think, like Amazon, they also try to maximize the revenue or the benefit that they recommend. Maybe also products, of course, what the users want and they're happy with, but maybe also I don't know if they also recommend products where they have a higher benefit, which they tell to the user. So it can be also.
Exactly. So I remember I interviewed one data scientist, and I was aiming at I told him, okay, there are two recommender models, and both of them have 4 out of 10 hits, right? But how can you say which one is still better than the other? So I was aiming at NDCG, right? So the position of recommendations, and he said, yeah, but if it's the recommender system for an online betting shop, I will go for the money. I will simply sum up the money that I get from the first model and then from the second one, and this will be my metric. And it was a clever idea. I mean, very simple, but okay. It's generating. It makes sense in the business case.
Yeah, there's the money, like in the Mediathek online, Netflix is the time that users spend there. So you have to then align this, the target variable. And also what you mentioned, but I'm not surprised that the model from AWS worked best because, of course, Amazon, they have good recommender engines in the online shop. Maybe they reuse it. So I wouldn't be surprised that they have really, really good algorithms over there. Maybe you could also tell a little bit about this AWS receipt. Is it in SageMaker, or how does it work in AWS that you can?
So it's practically they have a personalized section, so to speak. So in this section, there are a number of recipes that you can choose from, upon which you can build the model. So basically, once one goes into the AWS, one can specify a glue jobs. I think it's more on a machine learning ops side, but I think if I remember correctly, first is a glue job where the data processing and data preparation is done. So where all the incoming CSV files are aggregated into a separate CSV file, and this is prepared as input to a particular recipe, and then the recipe is the model itself. If I remember correctly, as I said, it's the hierarchical recurrent neural network, and there is also. So I think that the number of features that, at least the number of features that one can submit to the model is limited. I think the obligatory are the interaction features and item features. Obviously, interactions in terms of a tuples, so pairs of user ID, item ID, but also some other contextual features of the interaction, let's say time of the day and so on. And item features and then user features is optional, but one can also set it. It's limited, I think, to one of them is 10, 25, or 100, so it's limited. And one has to specify then the categorical variables, one has to specify the textual numerical variables and features, and then simply one can also choose the hyperopt of the person model. I call them person models. It will take a lot and it will cost a lot, but in the end, you will have the best possible model that is with this data exactly. And then simply the configuration file is updated, is set up, and then the once in the end, one then obtains the URL through which one passes the user ID, and which then serves the list of the recommendations, with some metadata, of course. Metadata is sometimes necessary for the customer to enrich the information on the items that are being served.
Yeah, sounds interesting. I have now maybe something more specific, as you mentioned also before. Like now you said you have to, the number of the features is limited for this algorithm in the receipt. Maybe in practice you have more features, and you mentioned in the beginning that you used dimension reduction in graphs. Do you have any method to reduce these features which you input before using it, like with the principal component analysis or neural network? Or do you have some techniques in this area which are
So
a little bit more specific?
that's a very interesting question, because it was just this week that we worked on it, because we were given a slot catalog of the games, and this slot catalog had a feature description which was practically the textual description of a game, right? So it was a text. So what we did, obviously, I mean, if we do any pre-trained model and if we embed it, it will be, I don't know, from 512 dimensions north. Right. And what we did is we considered two ideas. We considered the idea, okay, let's do the dimension reduction. And dimension reduction can be, we wanted to reduce it to practically 3D via UMAP, basically. And the other approach that actually we applied is we did dimension reduction with UMAP in 2 dimension. And then we did clustering. So we did HDB scan, and we practically identify the clusters. So we identify a new feature, which was the cluster label. So, I mean, in a sense, it was like a single dimensional reduction from a very high dimensional space. But this is what we did exactly. So it was a very, very nice. It was very nice approach, because we also gained some insights. So once we obtained the visualization, and once we did the clustering, we wanted to see if some of the features actually define the clusters. So let's say there is a feature genre, right? Games, specific genre or type of the game, right? Roulette games and so on. So we wanted to see if the clusters are determined by a particular value of the type of the game. Let's say roulette game considers only one cluster, exactly. So if this happens, right? If this happens, then it means that, I mean, since we already have the feature of the game type, then using the clusters will not be so informative, right? It will be a redundant thing. But the results were actually, so in the clusters, we got, we did the coloring, and we got pretty different colors in each of the clusters. So which means that the cluster itself can carry some, belonging to the cluster label can carry some additional information for the model.
But do you, from clustering, I now would imagine using some k-means clustering. Can you then, and you mentioned the labels, also we dive in really deep, so if you stop me if it's too deep. But if you have the clusters and you give them labels, can it be that, how do you define them? Because from automatically it doesn't say this is genre roulette or this is ball games and these are card games or something. You have then manually to define the labels, or it's just abstract labels that it's saying like 1, 2, 3. You have some IDs and then you just assign abstract IDs.
No, so the thing is, so apart from the description, so description is used for the high dimensional embedding, and then we get to 2-dimensional embedding, we get the clusters. But we also have, beside description, right, we have other features. We have features such as genre, type, and so on. And then we practically extract the data points, so the games that belong to a particular cluster. We do the same for all the clusters, and then we compare the dominant features, so to speak, the features that determine this cluster. So we go by feature, right? And then we let's say that there are, like, I don't know, four game types, roulette and whatever. And then we practically say, okay, let's color all the games in roulette with one color, all the games with a separate color. We do the same cluster, and if we get like 1-to-1 mapping, I mean nearly 1-to-1 mapping, then it means that making this cluster label or using this cluster label is a redundant information, because we already have this information, right? But if it's a mixed result, so if we cannot really say, okay, it is because of this particular feature that the cluster is formed, then it is reasonable to assume that the cluster label will add some valuable information to the model.
Yeah, but this you do then automatically, or it's a manual process that you have to check, okay, this could fit, or
No, it's actually it's an automatic process. It can be automatized. It can be definitely. I mean, we did the initial analysis, right, and it tells us, okay, it makes sense. But now since we have this information, it makes sense. We can simply remove the analysis step and just apply the cluster labels as part of the features.
Sounds interesting. Also the pipeline, but maybe we are really deep. I think it's also interesting to dive in normally in a podcast. But let's come a little bit back to higher level. What other interesting projects do you have, or what Falcony AI is doing, or do you have a product?
Okay, so there is one product which we have with a German company based in Hamburg, and they do debt collection, right? So their customers are banks, and banks have a number of clients, and these clients have loans with the banks. And this company wants us to build models that will predict, based on the debtor data, what is the likelihood that they will actually collect the money, so that they will collect the monthly payment, which is a interesting project. It is pretty much closed by itself, and it is a lot of tabular data, so methods like random forest classifiers and XGBoost work quite well. However, we recently started with a company that is sensor that produces sensors, and they monitor private and public networks for anomalies, right? And there the problem is now to detect anomalies, right? So they want to have models that will, predictive models that will, at a specific point of time and a specific geographical area, say which network cells are visible to the sensors. Right, and what actually they wanted, I published we from Falcony AI, we published a blog post about using graph neural networks for the investments, right? And there we said, okay, we did some mapping between the investors and the companies as a bipartite graph. And some from this company, they read this and they said, okay, we would like you to do something similar with our information. So we would like you to build a graph neural network that will consider sensors on one side, so one type of the node, and then cells on the other side. Right, and then you will have features along the edges, like if sensor senses the specific cell, there will be a feature of the interaction, right, of the scanning, such as the timestamp. And we want you to build practically the predict method that will tell us, based on the time and space, what will be, let's say at 1 o'clock, between 1 o'clock and 2 o'clock, what will be the visible cells in the whole network, which is a very interesting problem. We just started. We just outlined this week. We outlined the whole project and the timeline, and we had some ideas about how to proceed, to build the baseline, probably some multi-class classifier. We will have to check if it's feasible because of the number of classes. Maybe some time series such as ARIMA. We have members in our team who are very experienced with that one. I am not so much in the time series data. It's single dimensional for me. It's not really interesting. But graph neural networks will definitely be a very promising approach to this problem. And let's see how it will behave. I mean, there are countless ways of how you can approach the problem. The problem is actually very, very nice and clear cut. So yeah. It is quite interesting to be.
Yes, I think it's graph neural networks, like you mentioned. If you have time series, I read recently 2 research papers. They used graph neural networks to predict the earthquake prediction of sensors. And they have been performing quite good. So could be translated, because you mentioned also about sensors in networks. So it could be a similar topic. And maybe we can make soon another podcast and then tell about your experiences about the graph neural networks, which is a really hot topic. I think is also the next steps. It's quite new. I haven't seen so much in industry, in the finance industry. As mentioned, we're also doing a master thesis about this. But I also imagine that is entering more and more the business context and the industry. All right, so we are through with the topics which we discuss. At the end, I would like you to give maybe some data science tips for our listeners.
So data science tips. That's this could be inferred from our conversation. It is very necessary for data scientists to do some initial data analysis and to understand basically the nature of the data. I assume that they already have the understanding of the business. So what is the desired outcome for the customers, then perform a thorough data analysis, understand the distributions, understand why something is happening before picking a model, do the distribution of the, let's say, class labels, see what is happening there. And what I think it's very necessary now, especially in the times of ChatGPT, where everything can be like done in 50% of the time originally spent, I think that people are inclined to delegate most of the stuff, and which means that the in-depth knowledge is kind of lost. So I would advise that data scientists have some knowledge of the models that they use, like theoretical knowledge of the models that they use. Why using XGBoost is particularly good for this model, right? Why logistic regression is good? Why deep learning, convolutional neural networks? Would the simple graph approach be good here? So to have some theoretical knowledge about the models and its potential application to the data, right? Before applying experiments based on a number of models or all the models that they know, and then just collecting the best metrics. So I think this would be advice. One thing that we did for this investor is we started with this graph neural network, which was a very sophisticated approach. But what we forgot is to build a very simple baseline. So there was the number of companies that we were picking from was very, very few companies, right? So the pool of companies that we were picking from was small, which means that a baseline where you practically pick from the most popular, right, can actually produce quite good results. And it so happened, right? So it so happened that we did achieve the improvement by graph neural networks, but it was not like we were not amazed by the improvement, right? So we were amazed by the quality of the very simple baseline. So it's always a good idea, as I said, to do data analysis, to understand the business, build some very simple baselines, and then build upon it, right? So do not from the very beginning, do not apply graph neural networks, right? So think about it. I'm a very big fan of solving things very simply, if the simple solution is actually feasible. Exactly. So this would be my advice.
I can only confirm it's very good advice is not jump to the training of the model right away, and also start with simple models also as a baseline that you can compare. It's really important because now it's the hype. Everybody wants to do LMMs and solve all the problems with LMMs. Then before the neural networks, everybody wanted to solve with neural networks, and the simple basics, which are often maybe reaching nearly the limit with less computational power, less effort, can already solve.
Exactly.
Totally agree. All right. Thanks, Mirza, for this interesting insights about graphs, about recommender engines, about the data science tips. It's very nice to have you now.
Thanks, René. Thanks again for having me, and greetings to your listeners.
Das war's für heute in Data Science mit Milch und Zucker. Ich hoffe, du hattest eine lehrreiche und unterhaltsame Zeit mit uns. Vergiss nicht, den Podcast zu abonnieren, um die zukünftigen Folgen nicht zu verpassen. Teile ihn auch gerne mit deinen Freunden und Kollegen, die sich für Data Science interessieren. Wenn du Fragen hast oder dich in einem bestimmten Thema brennend interessierst, dann schreib mir einfach gerne eine Nachricht. Du findest mich auf LinkedIn, wo ich dich auch immer über neue spannende Themen rund ums Thema auf dem Laufenden halte. Zum Beispiel mit meinem neuen Buch Python Schritt für Schritt programmieren lernen. Außerdem findest du meine erfolgreichen Data Science Kurse auf Udemy. Du siehst, wir wissen, was wir tun, wenn wir wieder eine spannende Folge unseres Podcasts veröffentlichen. Vielen Dank für deine Zeit und dass du Teil unserer wachsenden Community bist. Bis zur nächsten Episode von Data Science mit Milch und Zucker.